In the arithmetic series with nth term un, it is given that u4 is 7 and u9 is 22. Find the minimum value of n so that the sum of the first n terms of the arithmetic sequence is greater than 10,000. The formula for the first n terms of the arithmetic sequence is given in a data booklet, and it says that it's n over 2 times u1 plus n minus 1 times d, where u1 is the first term and d is a common difference. So to consider this inequality in terms of n only, u1 and d should be found. We know that general term for the arithmetic sequence is u1 plus n minus 1 d, so u4 becomes u1 plus 3 times d, and it's 7, and u9 is u1 plus 8 times d, and it's 22. So we get simultaneous equations, and for any simultaneous equations we can do same operations with the left hand sides and the right hand sides, and we can see if we subtract both sides, u1 cancels. So let's consider the second equation minus the first, so it becomes 8d minus 3d, so 5d is 22 minus 7 is 15, so d is 3. Or directly from this you can see that from 4 to 9 there are 5 steps, and each step it's a common difference, so 5d is 15, 22 minus 7, so d is 3. And then you may consider this, substituting d, the 3 for d, and u1 becomes 7 minus 9 is negative 2, or just 7 minus 3 steps in opposite direction to get u1, so it's 7 minus 3 times 3, which is also negative 2. Now the required inequality becomes n over 2, 2 times negative 2, it's negative 4, plus n minus 1 times 3 is greater than 10,000. And using calculator we can consider two functions. One is n over 2 times negative 4 plus 3 times n minus 1, and another is 10,000. Window, definitely n is a positive integer, but to be more clear, let x be from negative 200 to 250, and y from 5,000 to 15,000. And we need this point. Let's find point of intersection. The first, the second, guess we need this. And it's 82 point something, but value of a function must be greater than, and n is positive integer, so we round up to the first integer, so it's 83. So n is 83. So it looks like this point of intersection is 82 point something, and we need its y value of this parabola is equal to this value, and we need it must be greater than, so we round up so that value of a function must be greater than, and n is positive integer, so it's 83. Another method to expand and simplify to get this inequality in the form an squared plus bn plus c is greater than 0, where a, b, and c are some coefficients, and you can see that here n coefficient in front of n squared is positive, so a graph of this function is concave up parabola. It looks like this. And another function is 0, so we need x-intercepts or zeros, and we can see the this to be equal to 0, and we can find, we need roots. We can find them using discriminant or also using a calculator. So we need roots, and actually we need only positive root, this value, and it also will be 82 point something, and we need the value of this function y, coordinate of this parabola, to be greater, and n is positive integer, so we round up to the first positive integer, and it's 83. To the nearest, we round up to the first, to the nearest integer. And that's all for this question.